What questions on the chart right do we want to see you do over? Okay. The ones I'm seeing the most are 2 and 3, and then there were more 5s than 1. So those 3. To find the line of best fit, you need to put that into your table. So I can see that a line is forming. To find the actual equation, use your x1, y1. So y1, your tilde, this is the line, mx1 plus b. And your equation would be y equals negative 1.5x or y equals negative 1.5x plus 0. Either or is fine. For number 3, combining like terms, we would need to distribute. So we have 2x minus 3 plus 4x minus 4z minus 6z minus 10x. And then combine all your like 2 plus 4 minus 10, so this would be 6, minus 10 is negative 4x. Negative 3 minus 4 is negative 7, minus 6 is negative 13. And then if I were to put that into Desmos, the original and the answer, I gave that, but I need to for that. I'm going to make the x's capital and leave the z's. Add insiders, change these both to different values. It doesn't really matter what it is. And then put in the answer we got, which was for negative 4x minus 13z. Those decimals should be the same, so that tells us this is the right answer. Questions on that? This one is not a done in Desmos, so you have to simplify this and you could check it in Desmos. So make sure you have all of your work. For number 5, I could check this in Desmos, but you still have to graph it. So I know this is going to be a solid line, shaded below, starting at 1 with a slope of 2. So on your graph, it will look something like questions on any of those? So make sure you have those written down and then look at your notes. If you did not grab an iPad, I need you to go grab one. In Unit 10, your curve of best fit, which is going to be very similar to your line of best fit, the steps, in the calculator and in Desmos, just the equations are going to be different. So I'm going to show you in the calculator first, and then I'm going to show you in Desmos, and just like the line of best fit, you'll have the option to use Desmos or the calculator just on this section. So first we're going to do quadratic. So you have all the steps on your notes. We're going to put in this set of data into your calculator. So first reset it, second plus 712. And then we're going to go into stat, go into edit, and then put in this data. And then once you have your data, you're going to go back into stat and scroll over to calculate. And then instead of number 4, we're going to go into quadratic progression, number 5. This screen looks the same. So stat, scroll over to calculate, number 5, step 2 on your notes. And then we want to find y values when x values are certain things. So we're going to store this, go down to store, and hit alpha trace, and enter 3 times. And then that would give you your curve of best fit. So we don't have a b in this case, so you wouldn't have a middle term. But our equation would be y equals negative x squared plus 7. And then you could find the y values from the calculator 2 different ways. One would be storing your value. So taking 3, just typing 3, typing in the STO, and then X and enter. And then going back and grabbing your equation at the trace and enter twice. That would tell you what your value is. Or you could go to the table. Both of these methods only work if you stored it. If you didn't store it, this won't work. If you go into second graph, you could find when your x is 3 and when your x is 4, and then write those 2 values down. So negative 2 and negative 9. Before we do this in Desmos, do we have any calculator questions on how we got any of that? Directions for Desmos start at the bottom and go to the next page. Yes.
Did you read that effect of the battery so you know the right way? There was one that was missing stuff to get in. Battery second.
in Desmos, just like for your line of best fit, add in a table. We're going to use that same table from before. It's also on the back of that first page also. And I can already see without drawing the line that it's making that U-shaped curve. It's going to be a quadratic. So just like our line of best fit, when you use the equation of a line that changed the x and y and squiggly lines, you're using the equation of a quadratic, but changing it. So when you type it in, you're going to do y1, the squiggly line to tilde, but then you're going to do ax1 squared in that order. Plus bx1, and then plus c. And you'll get that curve of best fit, and you should get the same coefficients constant for your equation. In Desmos, if you were finding your y values, you could just type in x equals 3 and see where those two lines cross, or x equals 4. Questions on how we find the quadratic curve of best fit in Desmos? Now we're going to do the same thing but with exponential functions. So back to your calculator. On the next page, go back into Stat, back into Edit, scroll up to the top and hit Clear, not Delete, and then scroll back down to get rid of the numbers in there. I can type in fractions, but you may not be able to because mine is the computer version. So the decimal or the fraction is fine.
Wait, how do we clear again?
Go up to the top, hit Clear, and come back down. Once you have your data in, go back into Stat, go back into Calculate, and we're going to scroll all the way down until we see 0 for your exponential regression. And then I'm going to do the same thing, store this in the regression equation as alpha trace, and hit enter 3 times. So my equation, my curve of best fit for this would be y equals 1 times 2 to the x, or just 2 to the x. And then we're going to do 2 of these values in Desmos and 2 of these in the calculator. Go into your table for this and find the values of 3 and negative 3. When x is 3, when x is negative 3, what's your y value? Did you find one of these values? Go to the table, find the value. Lexi, did you find one of these values? Go to the table, find the values. have one of these y values, go ahead and say that out loud, we're looking for when x is 3, when x is negative 3. And if you can't find it, now would be the time to ask. Or did you find one of those y values? How long did you find one of those y values? Did you find one of those? James, did you find one of those y values? Put it in the table, find one of the y values. Donovan, did you get one of those? Sky, did you get one of the y values? You guys are waiting on me or someone to say the answer, but you need to know how to do this. So if you're not sure where to find it or how to find it, you need to say something.
Whenever I put negative, it says like that.
This is your free minus. Okay.
I don't know.
Go to the table. Second graph. Yes. All the way to all of those directions. Go to stack. Go to calculate. But go to 3, what is 3? Because you have 2x, not 2x. You didn't store it in step 2. So, if you're not storing it, you're not going to get your table. Make sure you put the rest of this in. Follow the rest of the directions. Did you get there? That's right. So when x is 3, y is 8. Now we need to find negative 3. Once you have these in, you're following step 2. Once you put those in, make sure you're following step 2. Because you delete this stuff, so, or you do this, you put that in L1. Follow the directions for step 2. questions on how we found that? And then you're going to do the same thing in Desmos. Put it in Desmos.
Can I use the restroom?
After I finish this, yep. So now you put this in Desmos. And then just like your quadratic, you're going to put in the exponential equation. And it's going to be y1, the squiggly line, a, b to the x1. Find when x is 4 and negative 4. Did you get one of those answers? Okay. So you could type in x equals 4, or you could go along the curve. Um, 16 for x equals 4. What about negative 4? It's going to be a decimal. Did you put this in the decimals? Did you put this in the decimals? Start by putting in a table. Add the values. Put in this equation. It's a decimal or a fraction. Or 1. Type in x equals negative 4. And find where the two lines cross. Do you have any questions on how we find our server best fit or find values in the calculator or Desmos?
See how to survey for the
She's here.
So I'd have to see it. I'll see it in a minute. Any other questions? Type in x equals 4. Find where the two lines cross. Go to the next page. So you need to be able to identify which type of function you have based on the points, based on the graph, the equation. Your 3 different types, linear, quadratic, and exponential, are up there, along with the equations and how you would put them in Desmos. We're not redoing your line of best fit stuff, but it's up there so that you remember. For numbers 1, 2, and 3, plot all of those points on your 3 graphs, except for the typo in number 1. This should be 1, 1 instead of negative 1, 1, so just cross out the negatives. And go ahead and start plotting all of those points on your graphs. function type is the first one, linear, quadratic, or exponential? Linear. It's a line. You're not going to find that equation you could for your own practice. What about the second one? Quadratic, because it makes that U shape. We are going to find that equation in a moment. And then the last one?
Exponential.
And same thing. You will find that in a moment. Okay, so I want these four tables to find the equation of the quadratic. Put in your points and using Desmos or your calculator. And then these four tables find the exponential function.
Y equals 1x squared plus 2x minus 1.
2x minus 1.
Yeah.
I got what we all got on this side. Yes, great. What about our exponential? Yes,
Y equals 1, negative 2.
you don't need the 1, you just need the 2 the x. Right. So you have to be able to recognize the different types and find the different curves. Yes.
For quadratic, I got positive.
Yes, it should be positive, sorry. Because it's facing up.
What do you want?
Can you just let me have my moment?
You have your moment. Look, you got the whole rest of it.
Yes. Alright, go on to the next page.
How do you do this?
Like the whole thing, or just the list?
Everything.
Second plus 7 1.
I literally have.
There are a couple typos, so fix this in 7. The first one should be negative 1, 8, and then number 9, the last point should be 4, negative 9.
Which one?
7 and 8. 7 and 8. But we're not going to do those. We're going to move on to 10. Okay, so in this example, a coin is thrown off the top of the Statue of Liberty, is what that's supposed to say, which is 305 feet from the ground. The height h of the coin is recorded after each second t in the table below. Go ahead and put that into either Desmos or your calculator.
The T, the X.
Yes. Just based on the points, which one do we think this is, quadratic or exponential?
Whoa, mine looks like really different.
Yeah, mine looks way different.
Did you press the plus? Mine is also not zoomed out, so if you
Catherine. Is yours going like that?
Mine was going like that, but once you hit the plus, it like
So do we think this looks more quadratic or exponential? Quadratic, because it's making that U shape, that grab up. Also, in the context of the problem, if you're imagining standing on the top of the Statue of Liberty and you throw a coin up, which I wouldn't advise because it's dangerous, but if you throw it up, it's going to go up and then come back down because of gravity. So exponential functions don't do that. It doesn't go up and down. It just goes up or down in one direction. So it would be quadratic. I am going to show you both just to show you what would happen. So if I were to zoom out here, I could see the curve, but it doesn't work well. So my quadratic curve of best fit does fit this the best, but another way to determine that would be to look at the correlation coefficient, the R squared value. Whichever one is strong, closest to 1 or 1, that would be your answer. That would be the one you go with. So if I'm looking at both of my correlation coefficients, for the exponential is really weak, but this one is 1, so that would be my answer. So go ahead and write that equation down. Y equals negative 16 x squared plus 78 x plus 305. And then find the height of the coin after 7 seconds.
for how long?
7. Should know that. You put an x equals 7.
What's in minus 7?
Should be 67 feet. So if I put in x equals 7 and I find where that crosses, I'm going to have to zoom out. It is at 67, which makes sense because after 7 seconds, it's going to be closer and closer to the ground. It should still be at the 300s. Questions on any of that before we do one more example? Yes.
Tries your best.
Alright, go on to question 11. And start to put that into decimals of the calculator. I did want to say this. If you're finding both on the calculator, to find the correlation coefficient, you have to go into mode and go into stat diagnostics and turn it on. And then when you do your stat stuff, you'll see the R squared value also.
Do you have to do the plus for this one?
Plus 4.
Good. Actually, that's fine.
What's this?
Exponential.
So it is making that curve. I am still going to show you both. It is exponential. But if I did the quadratic, all of the points fall along this, and it looks like it could be that, but it also looks like it could be exponential. So this would be a case where you would really need to look at the correlation coefficient. This one is really close to 1, but this one is 1, so it has to be that one. If it is 1, that is your answer. If it's not, it's whichever is closest. So with our exponential, y equals 5 times 2 to the x.
How did you get 5?
So I will say in real life book clubs, because that's what this one's talking about, don't grow exponentially like this. But it would depend on the book, the author, the genre. But normally they may grow, but not like this. And then using your curve of best fit, how many members would there be in 8 years? Make sure you guys are trying this, not just looking at the face. So again, this isn't realistic for
280.
280. Again, this isn't realistic because normally book club members don't grow this much, but it could. And some books aren't as popular over time. So again, it could, but it could not. Okay. So then for, let's see, we have 37 minutes. I'm going to say for the next 15-ish minutes, I'm going to give you a new SOL packet. You need to be working on this for the next 15-ish minutes, and then after that, you can be working on other things, and I'll announce that. I'm going to give you guys the packets, and you guys are going to try it in the iPad. On the iPad? When your iPad goes into test nav, you're going to go into the practice items, Virginia practice items at the bottom. Go into Virginia, Algebra 1, the non-audio. So with this, I'm going to be checking this weekly like I was for the other SOL practice. On Tuesday, 1 through 7, I will be checking. So you can do more than that in this time frame. You can do less than that, but I would try to get at least those done. You guys can work together. In the test nav itself, it has Desmos, so you'll be able to use that. Use your calculator, use your notes, use each other. Ask me questions. This is a great time to figure out how do I do this in Desmos, how do I do this in the calculator, how do I do this in general. And then after that, enough that you can move on to something else. So I will say that number 5 in the app is not multiple choice, but on the packet it is. And number 10 is completely different. So once you're in Algebra 1, go into the non-audio. Great guys.
I've been open a while ago.
You'll be working on this.
I actually get
The other ones.
Let me know if you have
Are you talking to me or Sky? What'd you say?